Hello friends, this video on Amines part 28 is brought to you by examfear.com. No more fear from exam. The next question is ethylamine is water soluble but aniline is not. So let's see what is ethylamine and this is aniline. So if you see why it is water soluble, because this forms hydrogen bond with water. This is my, let's suppose, ethylamine. You see that it will form hydrogen bond with water. There will be more water molecules here, right? So it will form hydrogen bond with water. So this part is water soluble. It forms hydrogen bond with water, and this part is water insoluble. But if you see, this part is small here, only 2 carbon. Here if you see, this part is water soluble, but this part is very big part. And we have seen that as we increase the molar mass and this part increases, this NH2 part, which is water soluble, will not be able to bear the load of this water insoluble part, because this is my hydrophobic group. So if you increase the hydrophobic group, overall the compound will become insoluble. If you see, CH3NH2 is more water soluble than C2H5 NH2, right? This methylamine is more stable, more soluble than ethylamine, because this part is small. This is water insoluble part, but this is water soluble part. So if you keep increasing the water insoluble part, the solubility will decrease. So if you see, this is the solubility is decreasing. This is max soluble, and this is minimum soluble in water. The next question is, methylamine in water reacts with ferric chloride to precipitate hydrated ferric oxide. So let's first see what is methylamine. This is my methylamine, CH3NH2, and we know it is pretty basic, right? It is more basic than water. So this will react with water and it will form CH3NH3 plus and OH minus. Correct? Because this is basic, it will form OH minus. Now let's see FeCl3, because FeCl3 is forming ferric oxide. Let's see why. So FeCl3 is nothing but Fe3 plus and 3Cl minus. Now if I have Fe3 plus and OH minus in the system because of the methylamine, what will happen is the reaction will happen and it will become Fe2O3 and 3H2. Yeah, this is the reaction. Correct? Charge balance 3 into 2 plus 6, and this is 6HOH minus. Yeah, charge balance. So this is my hydrated ferric oxide. So for this reaction to happen, OH minus was required. And who gave the OH minus? CH3NH2. So methylamine was the one which gives OH minus for this reaction to happen. The question is, diazonium salt of aromatic amines are more stable than that of aliphatic amines. The reason is pretty obvious, because of resonance. So we have seen this aromatic diazonium ions undergoes resonance. So if you see, this is my structure. We have seen this. I won't draw the resonating structure once again. You can see in my previous video in the same chapter we have drawn the resonating structure for this. So because of resonance, it will have 5 resonating structure. This is stable because this is my actual diazonium salt and it exhibits resonance. That means it is stable. But aliphatic diazonium salt, they don't show any resonance. Since they don't show any resonance, they are not that stable. So the question is, Gabriel thalamide synthesis is preferred for synthesizing primary amine. Why? Obviously because if you see the output of this, you get only 1 degree amine, only primary amines we get. But the other reaction we have seen, we get 1 degree, 2 degree and 3 degree, all mixture, right? Mixture. But in other methods. But in this method, we get only 1 degree amine. So it's almost pure. You don't have to separate. So this method is used. Correct? Although amino group is ortho-para-dietering in aromatic electrophilic substitution reaction, aniline on nitration gives substantial amount of M-nitroaniline. Why? See, the question is, the amino group which I have is ortho and para directing group. Correct? So if I am doing a nitration, I see substantial amount of meta nitroaniline also. Question is why? See, this all happens in acidic medium, right? HNO3 in the presence of sulfuric acid, H+. So what happens here is, the moment I have H+, this NH2 since it is basic, it will react with this H+ to form NH3+. And this guy is actually meta-directing. Right? So with this guy, you see, is meta-directing. And this will easily lose H+ to come back to its normal state. This, if you see, we got because of NH3 plus intermediate, and this NH3 plus is nothing but meta-directing, because right in the acidic medium this aniline is protonated to give anilinium ion. This is my anilinium ion. Correct? Because this nitration is carried out in acidic medium, and in acidic medium this ammonia, this aniline, this is basic in nature, it reacts with H+ to form anilinium ion, and that is meta-directing group. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.